תודה רבה. בוקר טוב, אני הנס מגרמניה, ואני AI Solutions Engineer in Weights and Biases. And I think my English is better when it comes to machine learning, so bear with me with my English. So everybody nowadays talks about AI, and they talk about agents, and they talk about intelligence, but how often do people talk about intelligence agents? And I think this is where we really have a couple of challenges. Back in the 60s, we had one agent in the field. There was a one-to-one communication. I think everybody recognizes the person on the left. And nowadays, in 2025, we have many people, many agents deployed. It's really complex, and different teams were in the battlefield. So we have the challenge of communication. And this is also one thing where we have a parallel with the Model Context Protocol, because communication is resolved. The Model Context Protocol is an open protocol that enables integration between LLMs and different applications with data sources and tools. Doesn't matter what kind of application you're building. MCP is connecting it. And also last night I discovered an article that MCP basically is not only for LLMs or AI, people connected with their toaster. They connect everything with everything, similar to Bluetooth. It's not only for speaking, it's also for opening the door wirelessly. And MCP provides a very standardized approach to connect between different entities, and it's really powerful. And I think we'll only see, we have seen a lot already, but we only have seen a glimpse of what will unfold very soon. So we have a new challenge. We need to go from communication to observation. And with this challenge comes a new set of tools that we need. And gladly, what we see for AI, for agents, and also for generative AI applications, we have the observation part resolved as well. This is what Weights and Biases has been working on for the last 3 years. So I won't go into this full cycle, but we can see in the lower end is you can observe, you can deploy. So similar to agents in the field that you need to deploy, you also want to monitor them in action. You want to gather feedback in real time. So we already recall Bibi in the command center. And then you want to improve as you are deploying in action. And with that, it's really easy to get started. So back to what we can do with MCP style frameworks and Agentic. With Weave, what you can do is you can get installed very easily. So it's 3 lines of code to get started. We have pip install Weave. Then you have a decorator function, which is weave.op. And then you only log into the Weave console and off you go. So you don't have to change all your code. You only, similar to what you know with other tools, you only add those additional lines and then you're ready to go. So how does it look like in real life? Here we see an example. For example, this is the Weave user interface. And we see a couple of elements on the left. Most familiar is traces and evaluations. I will not go into all the details here. But one thing that I want to highlight is you have data sets that you can just create a new one. You want to browse or upload a file. So I just select a CSV file. I created one earlier. And in no time, you can see here are all my references from the file. So now, if I'm a non-technical person, this enables me to do this. And this is great because we, the technical people, we can then use this programmatically. So I uploaded a data set with verses from Isaiah. It's one of my favorite prophets. And you can see I have posted watchmen on your walls, Jerusalem. They will never be silent day or night. Of course, this makes me think of a monitoring function, watchman, shomer, and then never silent day or night. So we want to have continuous 24/7 overview. And then also another verse says, no weapon forged against you will prevail. We have seen that in the last weeks, but also what we see, so I would say no weapon, I might want to change this to no bug forged against you will prevail. Because in our use case here, we want to have all the bugs that are happening in our application, they should be tracked. Now, all those changes that I did in the user interface here, now they are updated. It's in version 1. And with that, I'm ready to go. So we can now go into the code and do stuff. So here I have one example where you can see there's a couple of dependencies. I will not execute this in real time now for time reasons, but happy to take this offline with quality time. So we install Weave, all the dependencies. yada, yada. Then we start an MCP server, and the server can run on my local machine. In this case, it's in the Colab, and we'll share the code after as well. And there's a couple of tools that you can see. So there's resources, tools, there's prompts. Here, for example, we have a tool that's BMI to calculate the body mass index. I can get the weather and so on. And all of those should be tracked automatically. So what I did here, I asked for the weather in Jerusalem, and then I got this result. And for the weather in Jerusalem, I want to see, okay, how hot or how humid is it? And now I can see very easily, here are my traces. I can see what happened. So here's the add tool. That's not the one. That's the demo effect. So fetch the weather. Oh no, tool error executing fetch weather. So again, I have a bug, and I want to find out what happened with the bug. So now what I can do is I can go into the code, and I get directly pointed to the part where the things crash. So this is one example where you can make your MCP work with the observability that you have, because communication is established by MCP, but the observability is what you really need. And this is where Weave comes in. Here we see another view. You can see on the left-hand side, I have a couple of calls. I also have a client that's running. I have different trace names, so I can easily see, oh, there's a debug error, and then I want to see what's happening. Apparently, a couple of those didn't work well. So for Jerusalem and Berlin, the weather didn't work, but here is a tool that worked. So I can see fast MCP call tool. I have a request which wants to add the numbers. So input is 3 and 7, and the output is 10. So this worked. Previously, if without the observability, I would only see things failed. So I would assume, oh, my server failed, or anything else. What failed? But now I know, no, the server is running perfectly. Only one tool that is failing. So I have this transparency because I log on a very fine granular level. And also you can see on the top, I have those charts where I can see what's the latency, what are the errors, what are the requests. And this way, it's really powerful to visualize if that's getting in the way. I can focus on the plain data again. I can do also filtering and more sorts. We'll see more of that. In case there are questions, add them in the chat, and I will be more available in the chat. So that's number one. Number two is, how about we want to create some agent? Let's get started with one agent. And this is also just a hand-wavy introduction, but you can take your time to read the full article here. So what we want to do is we want to have archived papers. And from the archived papers, we want to get always the latest papers. We want to see the best papers that have been published in the recent time frame. We want to extract the content from the paper. Then we want to generate questions towards the paper that can be helpful for summarization. Then we generate the summary, refine it, send the summary via email, and then we want to incorporate feedback as well. So this is what our agent should be doing for us. And what we then have is a couple of things. So this looks then here like this. I have a couple of operations that are all tracked, and I want to get an overview of all my operations. And here I'm coming back to my traces, and I have selected this op, generate summary from paper. This is one where here there's a couple of things I need to debug. And I get the transparency now in the trace tree. And when I look sharper, I see generate questions from paper 1, 2, questions, generate summary, excuse me, 3 times. So when I filter here now by summary, you can see there's a couple of duplicate steps. 3 times it's generate summary and 3 times it's edit summary. I want to improve that. So now, since I know that, and I can also see a preview of the result on the right-hand side, I have 3 times the same paper text and the same or similar questions. I want to improve this. Apparently there's a bug in my code. I need to fix this so that those for loops that are repetitive are optimized, and then I can easily see that now my approach, my agent is working flawlessly. And I can track that afterwards as well. So this is for one agent. Now we have people that come to us and say, well, with one agent, that's easy. I can do that. I can create that on a Friday afternoon on my local laptop. That's not that big a deal. Then what people are saying, show me multi-agent. And then we say, thanks, I'm glad you asked. Here we have an example where the goal is to build a GitHub repository summarization. So GitHub repos are very active. You want to see what's the latest, what's happening, and what are the recent feature requests, what are the pull requests, and so on. With that, we have here an example of a Crew AI Git documenter. So what we built is a couple of agents that work together to do exactly that. They have different tasks. So here, for example, we have a demo generator agent who has the goal to write and expand a basic usage for the repo. So how can you use that? It's basically like a README file generator. Then we have a follow-up analyst that should analyze what's missing in the documentation. And so on. We have a couple of more, and we want them to work together flawlessly. And with that, we need to instrument them. And with Crew AI, that's one way how you can do that. We have integrations also with other tools that are used in the space. You can just try it out on the documentation that we have. And then here I can see very easily, I have, again, traces. And of course, this is more complex now. I can see there's 132 steps. We can also see in the timeline, I can browse through the timeline to speed up. I can have very specific approach here. So if I want to go to the second to last one, I can just go to 136, and then I know, okay, how much time is consumed here, what's the dollar amount, what's the cost that I need to track, and so on. Also, when I have different agents, I want to see how are they performing. So here I looked at a filter. I looked at the column agent ops agent name, if it contains sum, because I was looking for a summarization. Now I can remove the filter, and this way I can now see on the left side the different agents that we have here. So I have the follow-up analyst, I have the diagram generator, and I can see in a summary what they are doing. And I can also then sort and do all the basic operations to see, okay, repo summarization is called 2 times, coder as well, diagram generator. Oh, demo generator is called more often. Maybe I want to look into this. How is that happening? Maybe the demo generator needs more iterations. So if I'm a team lead or managing across different teams, then I want to see how is this doing. And also if I'm the software architect or the engineer in this one, this really helps me to analyze and understand the project better. Now with that, that's only a high-level overview, but these are examples of what you can see from a multi-agent perspective and how the communication flows across those different elements. What we can see on the right-hand side, we can go into more details. Here, for example, I have a very specific input at step 136, so at the very end, the light LLM completion. And then I can drag, go into all the details, the roles, the content, very specific, and everything is tracked. So I don't need to memorize those things because here we have a database of very powerful metadata, and it's very complex, but I can always query it. I can see how the chat looks like that was used to create this. I can see how oftentimes it was called. I can also provide feedback. Maybe this one is too slow, so I can add a feedback, and I got teleported to some other place. I can add scores as well, either automatic scoring functions that come out of the box, or I can add human scorings. For example, as a human, is this correct or not? Or does this feel fair or not? And then you can add many more things as well. So this is one approach. We have all of the details documented on this fully connected post. And also you have full visibility into the repository that I'm sharing here. Now, what we still want to do is what do other people do? So people come to us and they ask us, okay, it's good, this is open source, a part of it is open source, but there's many other tools that are very competitive or better than what Weave is doing. What are the best practices? And for the best practices with Weave, we have seen what the foundational model builders are doing with weights and biases models, where we come from, and how to apply that to weights and biases Weave for Gen AI applications, agentic frameworks, and so on. And I want to share a couple of those best practices right now. So buckle up. This will be very code intense, but I think this is what the crowd likes. And then this one I'll share as well. We have basically two kinds of best practices for Weave. One is on the development side, when you create an agentic framework or when you work on a RAG or whatever Gen AI application you're building on top of existing LLMs or VLMs. And then we also have production best practices, because it's nice to build something and knowing this works really well from what we have seen in the lab, but you want to see it executing in the field as well. So let's get started. We have one best practice, which is that you need to ensure that a trace tree is meaningful and has all the workflow to understand the behavior. So when I go back to this example here, when I open the trace tree here, you can see these should be meaningful names. So QLI LLM call, chat completions, and so on. So I get an idea also when I look for the different agents. It makes sense to me. So in this case, looks good. But oftentimes you get started, you don't document and name your things well. You ignore naming conventions, even though you know better. And then things can get very not beautiful. And this includes, so the metadata naming conventions, if you are working with RAGs or have tool calls, MCP servers, we have seen one simple example of that. And by the way, Weave has its own MCP server, so you can, or weights and biases itself, you can use the weights and biases MCP server to ask from Claude, for example, how many runs did I run last week? Or what's the best run that ran this morning, or which LLM is the best as of today? Also for planning, chain of thought, and many more. So when should you do this? Anytime that you use the Weave op decorator. And the good thing about the operator is you can add it very specifically, exactly in those places where you need it. Sometimes you need to track all of your behavior. And this is where we have integrations, where this comes out of the box, for example, with the crew AI one that we have seen. But sometimes it's only a very microscopic element function that you want to track. And this is where you add then the Weave op. For example, here only for the tool call, and then you should get a response. Or for the RAG, you can always add the Weave op. And then the op takes care of everything of the input and output and will show up in your user interface in the ops section. So here I have more than 5 ops that were generated with this op decorator. And then you run and get an overview for your tracing. So this is very simple. Another best practice is that you can tag the traces where you have not a chaotic metadata approach, so it's not balagan, but it's really structured approach where you can add those Weave attributes, as we call them, and this gives you the business context, for example, production or staging or development, or you name it. Whatever you have, you can add those metadata here. So later on, even if you work with non-technical people, they can easily find what they have to look for. And there's another one where the auto patching can be disabled. So imagine you have a very large code base and the tracing part is very specific, and you don't want to have the auto patching with your frameworks that come with Weave included, because we have with the most used frameworks, we have first-class integrations. Then you can disable the auto patch in those settings during the init call. And once you have that, it will only trace the elements where you proactively add the decorator. Then next one, we have utilize OpenTelemetry for non-Python or TypeScript applications. I have seen in the chat something about other languages. I have not read it, but I saw C#, Java, Go. So in that case, you can always use OTel. Of course, OTel is not fully specified. There are some things in the specification that are still vague and a bit shaky, but very soon I'm convinced that we'll get there. So what you can do is you initialize OTel first, and then you initialize Weave, and with that you can track basically anything to weights and biases Weave. And this empowers then also other frameworks where you're working in other languages as well. You don't need to port everything to Python. I will pause here to drink a sip of water, and then we'll continue with one example that is for models access. If you have models and Weave access, before we go into the production tracing best practices. So we have looked a lot at Weave for GenAI applications. Many people use weights and biases models, the conventional weights and biases, with their runs. Now what you can do is you can connect both worlds. For example, you want to launch an evaluation in Weave as part inside of a run in models. So you can connect the two things. And what you would do is when you have a run log, which is recorded out of the box, you can visualize those elements. Now, what you can do is we have those in-context evaluations. So in the same run, 1DB run, there is a predict and score function. So when you call that, and then I can also share a code example afterwards, you have everything connected. And this is very beautiful if you have very complex approaches that need both the model training, but also the model usage part. And here you can see the evaluations. And once you have that, applied, you can, in the user interface, switch between runs in models and traces in Weave. Now, we have looked at the development side. We can also look into production. And we see a couple, not only a couple, we see many people that come to us, okay, building the application is fine, development's great, now production. What tools do you need to do this? And we have a couple of very mature users in Israel, but also startups, which are also very mature. So in general, mature demands, and they ask us, can we have production monitoring? And the short answer is a 3-letter word in English, it's yes. Here, for example, you can use the Weave up. And what you can do is for monitoring, we also have that in the user interface, you can specify the sample rate. So how much of your application, where you have an API endpoint that is running, how much of that do you want to monitor? So you can have a rate between 0 and 1. So here we would get 10% of all the traffic logged into Weave. And with that, we have then an overview how the production works. The application itself might not change that much, but maybe you want to create or collect user interactions. How do the users respond? Maybe you want to filter if there's bad language or there's toxicity and other things where you need guardrails. You want to filter those. Maybe you also want to collect the data to create real-time data sets or data sets that are from real users. You want to see what are the typos, what are the languages that people use when they work with our application, for example. This is also very powerful because you can see all the data in real time. You can interact with that. So here is one example, how you can create a monitor. On the left, I have the monitors part. This is very new, but it's really powerful. So you would add a name. Is it an active monitor? Here's the sampling rate. Of course, you would do this programmatically more easily. So you have everything in the code and versioned. You can specify what scoring function, what the judge model, and so on. And then you have your model in production and can monitor it. We have 3 more to go. So let's use the time. Also, what people come to us with is, how about PII? Can you redact PII? Because we work with sensitive customer data, it's really challenging. Yes, so with Weave, we have this redact PII function. And with this, you enable it as true. And then you can say what kind of, what fields you need to be redacted. So emails, for example, first name, last name, or whatever passport number. And there's also more details on our documentation. This is powerful because I remember 7 years ago, I did this manually and it was a nightmare until I found out that the lawmaker, our lawyers internally at my previous stop, they always said no. Even if I have it fully corrected and redacted, they said no, you can't use this. So this is really helpful function. Then people also use short-lived environments such as Cloud Run or notebooks or AWS Lambda. You want to ensure that you don't lose data because maybe execution environment is terminated prematurely. With that, best practices, what you can do is you specify that with the client finish, so with @exit, which is another library, you can specifically add client finish to ensure that the Weave client will finish, and this way you get all the data logged, even though if you have very distributed and Lambda style functions. Then another one that's less codey, but it's a good best practice as well. We have seen people use Weave for everything. What I have not seen people is creating their grocery shopping list with Weave, but we have seen things that come very close to that. So it's not a general purpose database. Maybe use the tools that are general purpose databases for that. So we have ClickHouse under the hood, really high performant, high velocity. But if you need to store images or large blobs or raw data or relational data, use the respective tools. So with that, yes, you can log images, videos, audio, and so on to weights and biases if that's part of your core function to build a GenAI application or an agentic approach. Yes, you can do that. You can do that at scale, but don't just use it for anything. This is where we recommend to use artifacts or an external database, or maybe an object store already does it, like S3 or Google Cloud Storage. Then what people also ask us, the technical folks ask us, okay, it's challenging. We work with these non-technical data annotators. The non-engineers, we tell them how to create an annotated data set. It's tricky for them. And here they have this sweet spot in Weave, where, as you have seen before, I can either upload a CSV file, as I did before here. This was locally on my laptop. But also, you can select different rows inside the traces, as we have seen. And with that, you can then add examples to a data set. So you can create that in the user interface. And that saves you a lot of time. But also not only a lot of time, this gives the non-technical person a very powerful way to interact with the technical environment that we as engineers are then scalably using. And this is really powerful to connect different people. So Weave does between non-engineers and engineers what MCP does between LLMs and tools. And with that, I would like to conclude that thank you. I think we have 1 more minute. I will look in the chat briefly. I do want to say, let's stay in touch. There's my LinkedIn profile on the right-hand side. And Toda Rabba, Am Israel Chai.
Thank you very much. It was